Hi there! Welcome to Septics 101. In this video, we're going to cover the basics of sewage and on-site septic systems. In the past, sewage was not properly treated, and the outhouses or cesspools that were used did not effectively remove pathogens. Pathogens are harmful disease-causing organisms such as bacteria, viruses, protozoa, and worms that can all be present in domestic wastewater and septic systems. They can cause diseases such as hepatitis, cholera, diarrhea, and other gastrointestinal illnesses. In modern times, rules and regulations have been established on how to properly dispose of sewage. When not connected to a wastewater treatment facility or public sewer, a home's best long-term option is an appropriately designed and installed on-site septic system. Clearly, it's important to make sure your septic system works properly, but first you need to know how your system works. In this video, we'll look at sewage and its potential impacts on health and the environment, and we'll explore the different types of septic systems and how they work. We'll also talk about being a responsible septic system owner and how to care properly for a system, as well as how to detect a system failure and get help. This is all to maintain the health of your household for you and your family, and protect the water quality as well as save you money. If you're looking to install a septic system, looking to purchase a home with a septic system, or simply wondering about your existing system, this video is for you. So, what is sewage anyway? Sewage is all the wastewater that comes from your house, your toilet, your dishwasher, and your washing machine, sink and shower drains, and all the solids and waste that comes with it. Up to 50% of domestic sewage is created by your clothes washer and toilet. Your dishwasher produces 3%, while your bath, shower, and sink faucets produce the remaining percentage. All this wastewater exits your house and enters your septic system. By the way, rainwater, surface water, and groundwater are not considered sewage. When a septic system is designed, the designer and local government will base the size and type of the septic system on the number of bedrooms in the home and the physical features of the property. For design purposes, it is assumed that a bedroom can accommodate 2 people. If you have more people living in a house than the system was designed for, the system can become overloaded and fail.
Site characteristics such as existing structures, slope, wells, streams, and other environmentally sensitive areas influence the system's design.
Did you know there are typically 40 million bacterial cells in a single gram of soil? Healthy soil is living and breathing and jam-packed with microbes that break down pathogens. It's the key ingredient in treating wastewater from your septic system. Once it reaches the soil, pathogens from wastewater adhere to the soil particles and are broken down by microbes before it seeps into the groundwater. The type and amount of soil on a property is one of the most important things to consider in determining the design of a septic system. The soil test, also known as perk test, helps determine the type and depth of the soil on the property. The soil test usually involves digging out a test hole 6 to 15 feet deep with a backhoe. This will include a ramp so that an environmental health specialist can safely enter the hole. In the test hole, they look at soil layers and soil types to determine absorption rates, and will measure the vertical separation or depth to a restrictive layer.
This test hole, for example, shows some of the best soil is several feet below the surface.
Sometimes the test hole will reveal a restrictive layer. In this case, the property has a high water table. The information gathered in the soil test will help the designer design a system that will meet the homeowner's needs and satisfy regulatory requirements. In determining the type of system to be installed, the concept of vertical separation is very important. Vertical separation refers to the depth of soil on the property between the bottom of a drain field and the top of a restrictive layer. You can think of this area of soil as the filter for pathogen removal. The distance will help determine the system type. A restrictive layer could be bedrock, groundwater, or an impermeable clay layer. It is the depth where water will no longer flow down through the soil and receive treatment. Let's look at the types of systems in use today. The most basic type of septic system permitted today for long-term use is the conventional gravity system. The gravity system consists of three parts: the septic tank, the drain field, and the soil beneath the drain field. In Maryland, the conventional gravity system requires a minimum of 4 feet of native, undisturbed, unsaturated soil beneath the drain field. As wastewater flows from the house into the septic tank through the inlet baffle, heavy solids settle to the sludge layer on the bottom of the tank. Lighter materials float to the top, forming the scum layer.
The clear liquid in the middle is known as the effluent. The effluent flows through the outlet baffle into the next component of the system.
If your system does not already have one, consider installing an outlet baffle filter. These filters fit into the outlet baffle of your septic tank and add an extra barrier that prevents solids from moving into the drain field or other components. Concrete baffles tend to degrade in septic tanks due to corrosive gases. Just remember, clean your filter every 6 to 12 months. Typically, gravity systems will utilize a distribution box or D-box
to equally distribute the effluent into each lateral pipe in the drain field.
Equal distribution of the wastewater into each lateral is critical to the long-term operation of the drain field.
Once the effluent reaches the laterals, it flows out of the small holes and into the surrounding soil where aerobic or oxygen-loving bacteria and other microbes treat the wastewater by removing pathogens.
This treatment is critical in protecting groundwater and surface water resources. Here, we can see a cross-section of the drain field. The perforated drain pipe sits on a level grade with gravel.
The gravel provides a space for the effluent to move.
Above the gravel is a fabric layer to keep the upper-level fine soil from moving down into the gravel.
Here's an example of gravel-less chambers used in place of rock and filter fabric.
Another type of conventional gravity drain field that was commonly installed in Maryland from the 1950s to 1980s is called a seepage pit or dry well. Seepage pits were typically constructed of dry stacked concrete block with diameters of 8 to 10 feet and covered by a concrete lid with an observation port. Seepage pits are considered an inferior design to soil absorption trenches and are rarely installed today. Pressurized systems may be used where sufficient soil is present, but the wastewater needs to be pumped to a certain area of the property. Pressure systems are also used when the soil type requires a specific dosing or when soil has limited permeability. Pressurized systems typically start with a septic tank, just like a gravity system. After the septic tank, the wastewater flows into a pump tank and is then pumped to the drain field where it's spread equally throughout the drain field lines. The pump tank accepts wastewater from the septic tank through an inlet baffle. The pump itself is located on the floor of the tank. There are two floats used to control the pump, the on-off float and the redundant off float. If the wastewater level were to drop below the pump could overheat and burn up. The redundant off float prevents the pump from turning on if there's not adequate wastewater to cover the pump. The on-off float turns the pump on as the wastewater level rises.
The effluent is dosed every few hours and is spread out across the whole bottom of the trench.
Some pumps operate on demand, while others use a timer to start a pump cycle. As the pump moves wastewater into the drain field, the level drops, dropping the float and turning off the pump, providing the soil with time to dry out between doses. The third and highest float is the alarm float. If the pump fails or too much wastewater enters the pump tank, the wastewater level rises and lifts the alarm float. If the alarm sounds on the control panel, push to silence it and then call a licensed professional right away. The alarm is there to let you know there's a problem with the system, so don't ignore it. Not all pump tanks utilize a float system. Some newer systems now use a transducer rather than on-off floats. Most pump tanks have some built-in capacity to handle wastewater during power outages. A pump tank has many electrical components that should be serviced by an experienced professional. Working with electricity around wastewater can be very dangerous.
A mound system is a type of pressurized system that may be used where there is less than 4 feet of suitable native soil from the surface to the restrictive layer, and perk rates exceed 60 minutes per inch.
Using specially engineered sand, additional vertical separation is built up above the native ground surface to achieve the 4-foot treatment zone that is required. The wastewater is applied at the top of the mound through a pressurized distribution system and percolates down through the sand and then into the native soil below.
Similar to the mound system, an at-grade system may also be used where there is a shallow water table, bedrock, or restrictive soil horizon.
For at-grade systems, the pressurized distribution system is installed within a gravel bed that is constructed just above the natural ground surface.
The sewage effluent from a pump tank is distributed through the distribution laterals, drains through the gravel bed, and into the soils below.
Now let's talk about non-conventional and less commonly used systems. In Maryland, non-conventional systems are categorized as either alternative or innovative, depending on the on-site soil permeability and the type of technology being used. Alternative systems are considered to be more reliable and may be used for repairs or for new construction on existing lots of record. Innovative systems are considered as experimental, may not be used to support subdivision of land, and are generally reserved for repairs on very difficult previously developed lots.
It should be noted that sand mounds and at-grade systems may be considered conventional or alternative depending on the soil permeability and soil loading rate.
For sites where soil permeability and other site constraints are particularly challenging, drip dispersal is an innovative septic system design that is commonly used in Maryland. Drip dispersal utilizes a pressurized network of proprietary drip tubing that is embedded with tiny orifices called drip emitters. In most applications, the drip tubing is installed at the root zone for 8 to 10 inches below the natural ground surface and separated by 18 to 24 inches.
Drip dispersal is a highly sophisticated type of sewage disposal system that utilizes a control panel, a filter, electronic solenoids, pressure regulators, and check valves to send microdoses of sewage effluent to the on-site soils at equal intervals throughout a 24-hour period.
Non-conventional systems require regular maintenance by qualified professionals and should be serviced at least once or twice per year. Now we're going to discuss proprietary aerobic treatment units, often referred to as ATUs. ATUs are commonly used for on-site sewage disposal where a higher level of treatment is required to address soil conditions or potential water quality impacts. In Maryland, there are a number of ATUs that have been approved by the Maryland Department of the Environment as BATs, which stand for the Best Available Technology for Nitrogen Removal.
BATs may be installed in lieu of a septic tank and are commonly incorporated into the design for pressurized systems, including sand mounds, at-grade mounds, and drip dispersal.
A blower or aerator injects air into a tank, enhancing the aerobic microbial action.
The treated wastewater from a BAT is considered superior to septic tank effluent and is expected to not only protect water quality, but increase the longevity of a drain field.
BATs are proprietary devices that are required by the manufacturer to be inspected at least once and sometimes twice a year by a manufacturer-certified representative. In Maryland, all BAT units are required to be inspected at least once annually by a certified service provider. So, in general, as soil permeability and depth to a limiting layer decreases, the complexity of the system increases. So do the cost and maintenance requirements. Non-conventional systems cost 2 to 3 times more than your basic conventional system. It's important to protect the system you have because replacement septic systems can be very expensive. Throughout the years, septic tanks have been constructed of many different types of materials. Many are single compartment, which are not as effective as two-compartment tanks. Some are not considered safe or effective. Metal tanks, for instance, suffer from corrosion, and the lids have been known to collapse. Cesspools don't provide primary treatment and are considered a threat to groundwater quality. If you have an older system installed prior to the 1970s, have your system inspected by a licensed on-site sewage disposal inspector to understand where your system components are located, how it is functioning, and whether it may be time to upgrade or replace the system. Septic systems need regular maintenance just like your car or home. First of all, you should know where all the components of your system are located on your property. An as-built or record drawing is a technical diagram of your septic system. For Baltimore County residents, well and septic information is maintained by the Department of Environmental Protection and Sustainability, and records for your property can be obtained by making a request through the Groundwater Management website. Record drawings are not always accurate, so make sure you verify it's correct. If you need to have your system located, make sure you also know the location of all utilities. Depending on the type of system you have, you'll want to know the location of your septic tank or BAT, pump tank, distribution box, and drain field or distribution network. Let's talk about what you can do to protect and care for your system on a daily basis.
Garbage disposals grind up unprocessed food and fine particles, which can clog components of your system like pumps or even drain field pipes and soil.
Use it sparingly. An alternative is to compost. Make sure you have an outlet baffle screen installed to protect the drain field. Doing your laundry has a big impact on your septic system as well. Space out your laundry loads to allow your septic tank to settle properly. If water flows too rapidly through the septic tank, solid material will not separate and could move on to more sensitive parts of the system. Limit the use of bleach. Bleach kills the helpful microbes which treat the wastewater. Liquid fabric softener can seriously alter the chemistry within the septic tank, hindering proper treatment. Installing high-efficiency washers and toilets can increase your septic system's life and save you money. Do not throw garbage into your toilets or feminine products and wipes of any kind, even those that are flushable. Kitty litter and pet waste of any kind should never go into your septic system. Some cleaning products claim to be safe for septic systems. This may or may not be accurate. Look for cleaning products which use everyday ingredients such as vinegar and baking soda. If you do use strong cleaning products, just use less. Never put paint thinners or strong chemicals of any kind on your drains. Many areas have disposal services for dangerous or toxic material. To dispose of unused medicine, bag it up and throw it in the garbage. Better yet, the Baltimore County Department of Health and the Baltimore County Police Department offer a drug take-back program. Drop-off boxes are located outside of all the county's police precincts. Check the county website for further details. Do not drain hot tubs and water softeners into your septic system. There's no need to waste your money on septic additives. Just use your septic system properly. Let's talk about how to protect your drain field. It's critical to protect your drain field and the reserve area. The reserve area is a part of the property set aside in the event that the current drain field fails. Protect your drain field from motor vehicle traffic, parked vehicles, heavy loads, and livestock. Don't dig, use heavy fertilizer or weed killer on your drain field. Also, be sure not to build anything over your drain field. Protect your drain field by diverting surface or roof water runoff away from it. Look for shallow root plants. Contact your local nursery or the Baltimore County Department of Environmental Protection and Sustainability for more information about what's safe to plant over septic systems. This tree was planted in a below-grade sand filter. The tree roots completely filled all the pipes in the sand filter and it had to be replaced. Your septic system requires routine maintenance. This includes inspection of all system components, pumping tanks, and cleaning filters when needed. And make sure repairs are performed. Risers increase accessibility to the system for you or a professional. They can also keep costs lower if a professional needs to service the system. If you do not have risers, you should have them installed. State regulations require that BAT units be inspected by a certified service provider at least once a year. In addition, all non-conventional systems require that the owner sign an agreement to regularly maintain their septic systems to ensure it is functioning properly. Also, when a property is sold or transferred, an inspection may be required to ensure the system is operating properly. This inspection must be performed by a licensed on-site sewage disposal system inspector. When you hire someone to pump your tank, make sure to hire only a licensed pumper. They should pump all the tank's contents and inspect tanks to make sure there are no leaks and that everything's working well. But remember, pumping your tank is not the same as having a certified system inspection. How often should you pump your system's tanks? It depends on your tank size, number of people in your home, and your water use. Generally speaking, you should pump it every 3 to 5 years. There are many types of potential repairs that will be needed to keep your system operating. They can include replacing broken baffles, repairing broken transport lines, balancing your D-box, replacing pumps, and much more depending on the type of system you have. If repairs are not performed in a timely manner, the system could fail. Symptoms of a failing system can include sewage surfacing over the tanks or drain field, slow drains, or sewage backing up into the home. If you see any of these problems, contact a professional and the Baltimore County Department of Environmental Protection and Sustainability immediately. Sometimes systems can be saved from having to be replaced. One way health departments detect a failing system is by using liquid tracing dye. The dye is poured into a toilet and flushed into the system. If the system is failing, the dye may surface onto the lawn or nearby waterways.
This photo shows the dye from a failing septic system near a marine water body.
By correcting small problems when needed, you prevent larger and more costly problems. If you do have a problem or failure with your system, there is financial aid available. The United States Department of Agriculture is one source of funding available for septic system repairs. Contact the Baltimore County Department of Environmental Protection and Sustainability for other resources available to you. I hope the information in this course has been helpful. Thank you for your time, and remember, as you responsibly operate and maintain your septic system, you're protecting the public health, the environment, and your pocketbook.